Relative velocity 2014, question 2a. We're given this information about three different ships, X, Y, and Z, and their positions and the times that they're in those positions at. And in part A, you're asked to prove that if X, Y, and Z continue with their uniform velocities, they will collide and find the time of the collision. Okay, there's a couple of different ways to do this one. I think really quickly we could say 2i plus 7j. Where is it going to be in an hour? Is it going to collide with z in an hour? In 2 hours? In 3 hours? These questions will always work out quite quickly, so we can see really quickly where we're going with this. Where's z? 12i plus 9j. It's moving at 2i plus 6j per hour. You can see we're getting quite close here. We've got 12 and 6 is 18. We've got 2 and 12, which is 14. So there's my 18i. What's the j positions? 6, 18, 27. So we have 18i plus 27j for z. And we also have 18i plus 27j for x. And you can see this has been moving for 4 hours. And this one has been moving for 3 hours. So they're going to collide at 2 o'clock plus 4 hours. 6 p.m. collision. Okay, let's look at another way to do it. Okay, so the x is going to be 2i plus 7j. 7j plus 4i plus 5j times t. And the z is going to be 12i plus 9j plus 2i plus 6j. That's an hour ahead, or t minus 1, because if the times are equal, we'd have to take 1 hour away. So for them to collide, the i's will need to be equal. So we have 2i plus 4it on the left, and on the right we have 12i plus 2it minus 2i. So what do we have here? We have I times 2 plus 4t is equal to, it's going to give me a 10i. So we're going to have I by 10 plus 2t, and for these to be equal, 2 plus 4t would have to be equal to 10 plus 2t. So 2t will be equal to 8. So t again would be 4. So 2 p.m. plus 4 hours is equal to 6 p.m. Okay, in part 2 we're asked when y will arrive at the collision to the nearest minute. Okay, at what time? So what we need to do is find to the nearest minute. What we need to do is we need to find out where y will be at the time of the collision, which is 6 p.m. So we've seen already, just go back up. Where was it at 6 p.m? 18i plus 27j. So 6 p.m. the collision occurs at 18i plus 27j. Now at 6 p.m. y has been moving for how many hours? It's the half-hour interval, so it's 3.5 hours. So y has been moving for 3.5 hours. So y starts off at 6i plus 9j, and it's moving for 3.5 hours at a velocity of, from above, 3i plus 4j. So it's speed. So what's that going to give me? 6i plus 3.5, 10.5i, plus 9j plus 14j. So 15i, no, not 15i, 16.5i, 16.5i plus 23j is the relative position of y. So So to get the relative distance away, we're going to take the difference between the i's and we're going to square them. So that's 1.5 squared, and the difference between the j's is 4 squared. And if we get the square root of that number on a calculator, it comes out as 4.3 kilometers. So that's the relative distance. We have the relative speed here, the velocity. So if we take time is equal to distance over speed, the time is going to be 4.3. Now we can see that's going to be 3 squared, the square root of 3 squared plus 4 squared. So the time is going to be, and we need to multiply by 60 to get the minutes. The time is going to be 51 minutes after 6 o'clock, 6:51 p.m.